presentation we're looking at trigonometry. Lesson objectives. To use trigonometric ratios to find missing sides, to use trigonometric ratios to find missing angles, and to use trigonometry to solve practical problems. This is a right-angled triangle. Has an angle of 90 degrees represented by a square in the bottom right, an angle theta, an opposite side, an adjacent side, and a hypotenuse. To find the hypotenuse of a right-angled triangle, this is the side that the right angle points towards. To find the opposite side, this is the angle, this is the side, this is opposite the angle theta. And the adjacent side is the third side out of the three. Now the sine, cosine and tangent ratios are defined as sine theta equals O over h, opposite over hypotenuse. Cos theta equals A over h, adjacent over hypotenuse. Tan theta equals O over A, opposite over adjacent. Now it is important that you remember these ratios, and the way that most people remember is through remembering SOHCAHTOA. Now we need to find the length of the side marked A in this triangle. So first of all it would be best to identify the sides. So opposite the right angle is our hypotenuse. Opposite our angle is the opposite side. So we can mark the A with O and the 12 with H. So we're using O and H. The ratio that has that is sine theta equals O over H. Now we take our values, our A, our 12 and our 35, and we stick that into that formula. So we get sine 35 is equal to O, which is the A, and over the hypotenuse H, which is 12. Then getting this, we need to rearrange this equation to A equals. Now in this case we would multiply both sides of the equation by 12. And we end up with A is equal to 12 sine 35 degrees. Stick that into a calculator. We get an answer of 6.88 centimeters to 2 decimal places. Now in this second example, I'm trying to find the length of the hypotenuse H in this triangle. So we already know that the H is opposite the right angle. Now in this case, the opposite side, the angle, doesn't have a side. So we're looking purely at A with the adjacent side and H for the hypotenuse. Now the ratio that has A and H is cos theta equals A divided by H. Again we need to stick in our values. So cos of 40 degrees equals, our A is 20, our H is little h. So we get cos 40 degrees equals 20 divided by H. Now we have to rearrange this to find, so we get H equals to get our answer. So times in both sides by H, we get H cos 40 is equal to 20. We want the H on its own, so dividing both sides by cos 40, we get H is equal to 20 divided by cos 40. Sticking this into a calculator, we get that H is equal to 26.1 centimeters to 3 significant figures. Now sometimes you may get description rather than a drawing of a triangle. So in this case we need to find the angle theta given that the opposite side is 3 centimeters and the adjacent side is 4 centimeters. So first of all we need to draw our own triangle with the angle theta. Then the opposite side is one opposite the angle, so that will be the 3 centimeters. Hypotenuse is opposite the right angle, so we have the other side is the adjacent side, which is what we need for 4 centimeters. So 3 centimeters for the opposite side, 4 centimeters for the adjacent side. tan theta equals opposite over adjacent, sticking in the values, tan theta equals 3 over 4. Now in this case we need to find theta, so we'll need to do the inverse of tan to both sides of the equation. We'll get theta equals tan inverse 3/4, stick that into a calculator, we get 36.9 degrees to 3 significant figures. Now yet again, this example comes from a practical situation, but for a sketch we can get the right angle triangle from it. So a window cleaner has a ladder which is 7 meters long. The window cleaner leans it against a wall so that the foot of the ladder is 3 meters from the wall. What angle does the ladder make with the wall? So a quick sketch of the situation gives us our right angle triangle. We have our ladder is 7 meters long, so that's the one on the diagonal. The foot of the ladder is 3 meters from the wall, so the bottom side of that triangle is 3 meters. Now again, the side that's opposite our hypotenuse is opposite our right angle is the hypotenuse. The side that's opposite our angle is the opposite side. So our 3 is the adjacent side, and our 7 is the hypotenuse. So A and H means we're using cos theta equals A over H. Sticking in our values, cos theta is equal to 3 divided by 7. To undo cos, we need to do cos inverse to both sides. We get theta equals cos inverse of 3 over 7. Sticking that into our calculator, we get 64.6 degrees to 3 significant figures. In example 5, another practical situation. From the top of a vertical cliff 100 meters high, Andrew sees a boat out at sea. The angle of depression from Andrew to the boat is 42 degrees. How far is the base of the cliff? From the base of the cliff is the boat. So a quick diagram of that. Our angle of depression, it's 100 meters high, the cliff. We have an angle of depression of 42 degrees, and using our parallel lines rules, the angle in the triangle is 42 degrees. Now we need to mark our sides again, so opposite the right angle triangle is there, is the H. Opposite our angle is the 100, so that's O, and it's actually the A that we're interested in this case because we want to know how far from the base of the cliff is the boat. So it's O 100 meters, A is what we actually want, so we're using tan theta equals O over A, tan of 42 degrees equals 100 divided by A. Again we need to rearrange that to A equals. Timesing both sides by A, we get A tan of 42 degrees is equal to 100. We need to get A on its own, so we divide both sides by tan 42. We get A is equal to 100 divided by tan of 42 degrees, and sticking that into our calculator, we get 111 meters to 3 significant figures. Final example, example 6. We have an isosceles triangle represented by the two short lines on the two high sides. So those two sides are equal, of 7 centimeters, and we want to find the length x in the diagram above. Now it would appear that there isn't a right angle triangle in this problem, but if we redraw that diagram, splitting it into half, we can get two right angle triangles, both the same but flipped, and we've halved the side at the bottom, so x becomes two lots of a half x. Now from that we have our right angle triangle. So from our right angle at the bottom, opposite that is the 7 centimeters, so that's our hypotenuse. Opposite the angle 53 degrees is the height of that triangle, so the 0.5x is our adjacent side. The 0.5x is our A, 7 centimeters being opposite the right angle is our H. So A and H, we're using cos theta equals A over H. Sticking in our values, cos 53 is equal to 0.5x divided by 7. We need to rearrange that equation to x equals, so multiplying both sides by 7, we get 0.5x is equal to 7 cos 53 degrees. Doubling both sides to make it x equals, x is equal to 14 cos 53 degrees. Sticking that into a calculator, x is equal to 8.43 centimeters to 3 significant figures. And this concludes the presentation.